Okay, everybody, welcome to this channel. In this series, I would like to show you some of the most frequently asked questions in A-level math exams. And in this particular video, I would like to show you some hard computations with binomial expansions. And you must have seen the previous videos, binomial expansions has some quite useful applications in terms of approximating functions and analyzing its properties. But in this video, I think we should get the foundations down, which is actually do some computation here. Well, you might think that computation is one of the worst things about mathematics, but unfortunately, every great math based on some calculations, and all those calculations are necessary to get the right answer. So let's begin. Part A, find the binomial expansion of 1 plus px to the power of minus 4, and you can show px is less than 1, okay? So we do not need to worry about the convergence in ascending powers of x up to and including the term in x cubed, given each coefficient as simple as possible in terms of the constant p. 3 mark. So we can just apply the formula here because we can have 1 and px, these are fine. We don't need to know any other manipulations. So first part, 1 go as 1, and the second term is, well, minus 4 times p, so basically minus 4px. And for second term, we have minus 4 times minus 3 over 2 factorial px squared. And third term, we have minus 4 times minus 3 times minus 2. Wait, I think a mistake here. It should be minus 5, and minus 6 because it's n minus 1. Sorry, my mistake. Over 3 factorial px cubed. And now we just need to simplify it. 1 minus 4px plus 10 px squared minus 20 p cubed, sorry, it's p squared x squared, p cubed x cubed plus ox4. Okay. So ox4, wow, I might just delete it. You can just say plus dot dot dot. But ox4 basically means that something in order of x4, right? Because every term onwards has minimum order of x4, and everything else, x5, x6, when they're approaching 0, they just vanishes too quickly. So we just say it grows roughly like x4. Okay, that's part A. And now fx is 3 plus 4x over 1 plus px power of 4. Again, px less than 1, so need not worry about convergence, where p is a positive constant. Cool. So in the series expansion of fx, the coefficient of x squared is twice the coefficient of x. And b, find the value of p. How are we going to find the value of p then? Well, it mentioned a series expansion. I think we must have to show that what is the actual expansion of fx. So let's begin. 3 plus 4x, we can rewritten 1 plus px to the power of 4 as 1 minus 4px plus 10p squared x squared minus 20p cubed x cubed plus some constants. Sorry, not constant, plus some higher order terms. And it involves some statements about coefficient of x squared and coefficient of x. What is the coefficient of x? How can we have x in this multiplication? So either going to have 3 times minus 4px or plus 4x times 1, right? Which is minus 12px plus 4x, which is 4 minus 12px. And this is, okay, this is your expansion, sorry, coefficient of x. And what about x squared then? Well, we have similar things. We have 3 times 10p squared x squared. We have 4x times minus 4px. And finally we have, we don't have anything else. either going to have 1 times x squared or x times x. If we have another x squared term here, then we have something x squared times 1, which would also give rise to x squared term. And we may just expand it. We shall have 30p squared minus 16p x squared. And let's re-look at this statement. Coefficient of x squared is twice the coefficient of x. So 30p squared minus 16p is equivalent to twice 8 minus 24p. Great. So this is your statement here. Rearrange it. 30p squared plus 8p minus 8 is 0. We can cancel the factor of 2, so 15p squared plus 4p minus 4 is 0. Is it possible to use basically factorization straightforwardly? I think it'll be quite tricky. Let's try 5p 3p 2 plus 2p minus 2p equals to 0. Let's verify it. So 5p times 3p gives you 15p squared. That gives you 10p. That gives you minus 6p. So yes, 10 minus 4 is plus 4. So sorry, 10 minus 6 is plus 4. And that multiplies together to give you minus 4, which means this is indeed the correct expansion. And p is either positive 2.5 or negative 3/2. Sound. So the value of p is 2.5 as we have calculated. And for the last part, hence find the coefficient of x cubed in the series expansion of fx, giving your answer as a simplified fraction. What is the series expansion of x cubed? We're going to have 3 times minus 20p cubed, right? So minus 60p cubed x cubed plus 4x times 10p x squared, 10p squared x squared. So 40p squared x cubed. Forty 2.5 squared minus 60 2.5 cubed. Let's just put in the calculator. You should have minus 687.5 as your answer. Okay, great. That's the end for this question, and let's summarize it. So in the first part, nothing too tricky, just apply the formulas, but be careful, it's n minus 1, not n plus 1. You might just say, well, 4 minus 1, 3. 3 minus 1, 2. Very straightforward, isn't it? But it's not, because they're negative numbers in this case. See, so you can see even great math, every great piece of great math needs some calculations, and all calculations needs great care, otherwise you can't get anything. Please be careful with everything you do, okay? Those mistakes are very easy to make and very hard to notice sometimes. You might just convince yourself, yes, because 4 minus 1, 3, 3 minus 1, 2. That's like one of the instincts you're going to have by now. But, I don't know, be careful, and you can probably avoid these questions. And for part B, quite interesting because you might not be very familiar with the expansion of a rational functions. So basically polynomial of another polynomial. And actually it turned out not to be so tricky, because all about it is basically you multiply the top polynomial with the series expansion in your denominator. And what really important is basically evaluating and equivalating the coefficients. The key part to approach part B is how you're going to expand the two brackets to achieve the terms of x squared and terms of x and x cubed, right? You can see, because even though we're multiplying with a infinite series, but some basic properties of multiplication is still contained. For example, we have distributive laws, right? We can multiply inside the brackets and rearrange it. And what I mean is here, if you want to have x squared, you either have some constant times x squared term in your expansion, or the x term times the x term in your expansion. You can't have anything else. Same principle applies to x and x cubed. And if they want you to find the constant term, it must be the two constant terms multiply each other, right? But of course, evaluating is always hard because p is not a constant. You're going to carry the expression of p all the way to the end, where you have a nice quadratic equation. Okay, and always be careful with quadratic equations. Sometimes you might convince yourself you find the correct factorization, but always remember to verify if it is actually the correct expansion. Otherwise, you will not have the right answer. And it's a shame because you're just one step away from finding the correct solution. There's no point to just lose 1 mark here. Every mark is critical in your exam because there might be some other questions you can't do. And every mark, if you can do the question, please make sure you got them all. Okay, and for the last part, again, same principle here, you find how we can approach x cubed. So how we can deduce x cubed here. Either you have x times x squared, or 1 times some constant times x cubed. Nothing else. Be careful with calculations, use a calculator if you can, and it should not be too hard. The reason why I showed this particular question is because it has some quite hard computations. Let's come back to the point where you might understand the theorems, you might understand how everything works, you might even understand how binomial theorems is approached, but in your exams there are loads of computations, and the speed of computation is really important as well. Because in a time-limited exam, it's most important to get the most marks in a limited amount of time. Even though you might understand all the questions in limited time, but that's pointless in the exam. If you want to get high marks, you must practice yourself with all the computations. Even like me, I might make some mistake here because I haven't done proper A-level exam for a lot bit of time. However, the practice is key to approach all the computations. And I say that's the end for this question. See you in the next video. Bye bye.